Hey, good afternoon. It's 1:39 p.m. here on Tuesday, November the 3rd. This video we are talking about being able to convert circular motion into linear speed. So basically anytime a thing is or an object is moving in a circular motion versus straight, they're kind of going round and round about the same location, but the thing is they still cover a certain amount of distance, right? Although they're about at the same spot. And hence, being able to convert that circular motion into linear speed just connects better with us, and there are situations where we need to do so. So there are two examples, or three examples, and two formulas. The first one listed here is W is equivalent to theta over t, and W is referred to as the angular speed. Now theta, of course, is the angle. However, please keep in mind that this theta needs to be in radians and not degrees. All right. The other one, which is V, then V is your linear speeds, sort of speed that we're more familiar with, miles per hour, kilometers per hour, centimeters per second. This is something we're very familiar with, and that can be simply written as the product of the radius times the angular speed. And if we don't know angular speed, then we use this first formula to first find the angular speed, and then use that and plug it in the second formula to get to linear speed. So let's go ahead and look at some examples. I have this first one here where we have a tire that rotates 8 times a second. The tire has a diameter of 8 inches. Find the angular velocity in radians per second. So register that in your mind that this is talking about finding angular velocity. The letter that represents that is this curvy looking W, and they're also very specific that they want it in radians per second. So let's gather the information that's already given to me. The first piece given to me is that this tire rotates 8 times per second. So in every second goes about 8 times. Now I'm going to convert this to revolutions, 8 revolutions per second. Right, in terms of rotation, it's 8 revolutions per second. The second piece of information given to me is the diameter. Diameter is 8 inches, and hence I can conclude that the radius is 4 inches. Since they're asking me for angular speed is theta over t. So I'm like, okay, to be able to find it, I obviously need to know the formula. It's theta over t. So if I can substitute theta and if I can plug in t, I should have angular speed. However, they did not give me theta directly, right? Instead, I have this terminology of 8 revolutions. But the thing is that I know that one whole revolution is 360 degrees, and you all know that. However, since I can't use degrees, I'm going to use radians. So the equivalent of that in radians would be 2 pi. I can take this and I can convert it into radians, but this is just something that you need to register in your mind and remember or memorize, to put it that way. Just like you have this memorized, let's go ahead and memorize this as well, that in radians, 1 revolution is 2 pi. So if 1 revolution is 2 pi, but this time, hold on, let me rewrite that. 1 revolution is 2 pi, then 8 revolutions, which is what it's making every second, would be simply 8 times 2 pi, right? And that is the theta. That is the theta. That every second, this tire makes 16 pi radian angle per second. All right. So that's that. I got the theta. I was like, perfect. Then I can take this theta and I can put it in the formula, 16 pi. Or I should rewrite it down here. Let me rewrite this down here. That equals theta over t. So I found theta. And then t is, t, if you remember, is like per second, right? That's how fast it's going every second. So you can put down 1 second there. Right? And I have kind of found it out, except that we can go ahead and do 16 times 3.14. Go ahead and find that product. So we have 50.24, and this is radians, right? Because we converted it to radians, and it's automatically per second because we have seconds in the denominator. And if you notice, they wanted angular velocity in radians per second, and that's exactly what I gave them. All right, that's one example. Another example, which takes it to the next level, is this one, and we did this in class as well. We have another bicycle wheel. This has a diameter of 78 inches. So let me register what has been provided to me. And hence radius is 39 centimeters. The other thing, this wheel rotates at 120 revolutions per minute. 120 revolutions per minute. What is the linear velocity of the bike in kilometers per hour? So they're specific, they want this in kilometers per hour. Let's see what we get it in, and if it's not in kilometers per hour, then we will change at the very end we'll convert it into kilometers per hour. So this is given, and what is asked? Linear velocity, radius times angular velocity. I'm like, okay, I already know radius, but what's the angular velocity? If I really don't know the angular velocity. So that means I first need to find angular velocity. Once I find that, then I will take that answer, plug it in that first formula. Formula 1, Formula 2. And that should help me find it out. So let's find angular velocity first, because without finding angular velocity, I really can't use formula number 1. Now, angular velocity, again, just as given up there, is theta over t. So what angle is this wheel making every minute? Use that same information we did earlier. 1 revolution is 2 pi radians. So 120 revolutions would be 120 times 2 pi, which is 240 pi. Does that make sense? And that is our theta. It's making this many radians every minute. So instead of theta, I'm going to put in 240 pi. And then time in this one is per minute. So basically 1 minute. Okay, I found W. Now you can go ahead and do 240 times pi and get the answer here. But I would just do it at the end. Now that I have angular velocity, now I can use that first formula. Radius is 39, and angular speed is 240 pi. And then if you notice, in the denominator we have minutes. And also notice R was given in centimeters, so it's 39 centimeters. If I were to separate the units, centimeters per minute, and it's 39 times 240 pi. And that would turn out to be 29390.4 centimeters per minute. That is the linear speed. That's pretty acceptable, right? Except what happened here was they wanted it in kilometers per hour, and I have it in centimeters per minute. So I need that quick conversion at the end. And I'm going to use dimensional analysis. You all have used it in chemistry and physics. So this is centimeters, and I have 1 minute in the denominator. So one at a time, I'm going to do this conversion. I'm going to start with centimeters. 1,000 centimeters is equivalent to 1 kilometer. Now centimeter cancels. And I already got kilometer, so I'm good there. Now at the same time, I want to convert this minutes into hours. Now 60 minutes is 1 hour. And now minute cancels. So automatically, this conversion will be in kilometers per hour. I need to take this times that divided by that. So times 60, and then divide the final answer by 1,000. 1763.4 kilometers per hour. So one acceptable answer is centimeters per minute, but since the question was very specific, they wanted me to convert it to kilometers per hour, so I had to do this whole conversion here using dimensional analysis. All right, okay, let's look at one more example. We have this child. He seems to be having some fun. What he did was he tied up a rock at the end of a 3-foot rope at the rate, and he's spinning it at the rate of 160 revolutions per minute. So radius is given to be, you can see pretty decent picture drawn there, feet, and then he's going 160 revolutions per minute. And hopefully by now you're kind of getting the idea, since he's going 160 revolutions a minute, 1 revolution is 2 pi, so 160 revolutions is going to be 160 times 2 pi, which is 320 pi. Right, that's the theta, or that's the angle that's being made every minute. Okay. This question is asking me to find linear again. So linear is radius times angular. But to be able to use that, I first need to find angular. And angular is theta over t. So let's do that. Theta over t. Theta I just found is 320 pi. T in this case is per minute, so 1 minute. And I have found angular velocity. I'm just going to take the way it is and plug it in the linear velocity formula. Radius is 3. And this is 320 pi. And if you notice, and 3 is in feet, right? Feet. So it's feet. And then per 1 minute, so per minute. And that's automatically the unit that I got it in. Now, this question wasn't very specific. They didn't say find it in feet per minute or, I don't know, miles per hour. They didn't say that. So I'm not going to do any conversions. All I'm going to do is multiply these 3 times pi. That turns out to be 3014.4 feet per minute. MIN. And that is the linear velocity of this rope. So if this rope, instead of going about in circular motion, if it was going straight, every minute it would cover 3014 feet per feet. All right, that is it from my side. Over and out. I will see you later. Bye.